Good morning, everybody. It's a nice, cold, rainy day here in Norman, perfect for talking about drought. Welcome to the webinar series on managing drought in the Southern Plains. I'm Mark Schaefer with the Southern Climate Impacts Planning Program. I'll be the moderator for today's webinar, and Rachel Riley, SCIPP Associate Program Manager, is managing the webinar. The topic of today's webinar is the U.S. Drought Monitor. We will hear from three presenters on aspects of how the Drought Monitor is produced and used. As usual, we first will begin with a drought update and outlook from Brian Fuchs, climatologist and drought monitor author from the National Drought Mitigation Center. Brian will be followed by Mark Svoboda from the National Drought Mitigation Center and U.S. Drought Monitor author, John Nielson-Gammon, Texas State Climatologist and contributor to the weekly U.S. Drought Monitor, and Chad McNutt from the National Integrated Drought Information System, or NIDIS. Mark will talk about how the Drought Monitor is produced, what information sources are used, and how the monitor is used in agency operations and planning. John will detail the state input that provides additional detail that is not otherwise possible from the national depiction, including several innovative tools they have developed to diagnose drought conditions. Chad will follow with a perspective on how these drought monitoring efforts tie together in a national strategy on improving observations, responsiveness, and early warning. These presentations will be followed by any state climatologists who want to give a brief update on conditions in their states. I would like to recognize the support of those who made this webinar series possible: David Brown, NOAA Regional Climate Services Director for the Southern Region, Mike Hayes with the National Drought Mitigation Center, and Chad McNutt with NIDIS. We also greatly appreciate those of you who join us in this webinar series and recognize the valuable time you are committing to participating. These webinars are held on the second Thursday of each month. A shortened webinar that features only the drought update and outlook and state climatologist comments is offered on the fourth Thursday of each month. Each webinar is recorded and posted on the SCIPP YouTube channel. The PowerPoint slides are posted on the NIDIS Drought portal, drought.gov, in the Southern Plains section. A two-page PDF summary will be produced following the webinar and will be available next week on the NIDIS portal, SCIPP website, and SCIPP Facebook page. The webinars are designed to improve communication across our region to help those agencies and organizations that are managing aspects of the drought. Your interests and needs are important to us. We encourage you to help us select presentation topics either through the online poll that you see on your screen, through the chat box, or by emailing or calling SCIPP. We welcome suggestions on presenters as well as topics. The topic for our next full webinar on April 12th will be ecological impacts, including wildlife. You may ask questions or make comments at any time through typing in your chat box. We will address questions at the end of the presentations. We will put up a list of resources, including these links, again at the end of the presentation. I will now turn it over to Brian Fuchs for an update on drought conditions and outlooks. Brian?
Thank you, Mark, and good morning, everyone who's out there in the audience. Again, I'm Brian Fuchs. I'm a climatologist at the National Drought Mitigation Center and one of the national authors for the U.S. Drought Monitor. Going to the first slide, here's a depiction of the latest and greatest U.S. Drought Monitor product, and what we're seeing over the last several months is almost a tale of two regions of the country, and almost three if you want to look at the western U.S. by itself. But we're seeing some developing dryness that has been ongoing through the winter over much of the western United States. And that has started to show up on the map as we see an influx of not only D1, but some introduction of D2 into the western U.S. In the southern U.S., we're seeing quite a bit of improvement with a fairly wet La Nina pattern that was pretty much unexpected for the most part, all the way from Missouri through eastern Oklahoma, parts of eastern Kansas and eastern Texas, as well as into Louisiana, Arkansas, and portions of Mississippi. And you can see that over the last few weeks, if you are following the map, quite a bit of improvement through this region, and even the intensities of the drought in portions of Texas and Oklahoma have seen some improvements as well. This wet pattern has been going on now for the last several months, and as I go forward with this talk today, we're going to look at to continuing at least into the short term. And then we have some regions that include New Mexico and West Texas and portions of the Texas Panhandle and Oklahoma Panhandle. And what we're seeing is this area has not seen the substantial improvement or the rainfall or snow associated with other portions of the region. And then we also see what's happening down in Florida and the southeast, that even though there has been some rains, you can see this very strong gradient of where there is no drought, and also where we've seen drought intensification taking place or even spreading through that region. Going to the next slide, we're going to see a regional perspective, and this really highlights, you can almost draw a line from the northeast to the southwest that cuts Texas in half and catches portions of eastern Oklahoma. And you can really see that has been the delineation line of where most of that precipitation has fallen to the east of that line. And we have seen some improvements, and I'll let John talk on this further, just really what they're seeing in Texas, especially out in the western part of the state, where we're really seeing quite a bit of drought still existing. And looking at the table associated with this product, you can see that currently we have about almost 11% of the region in D4 drought, and about 67% of the region in drought of any level. And compared to a year ago, that's about where we were, because we were at about 68.5% a year ago. So looking at where we were a year ago to where we're at now doesn't really give us a good story of where we've been or the recovery that has been taking place. The next slide. The change map kind of highlights what I spoke about with this improvement, and especially in the lower right-hand corner, the 6-month change. You can see that the greens and blues are showing anywhere from 3 to 5 class improvements on the drought monitor through this time. And then you can really see out in the western U.S. and especially over Florida and portions of the southeast where we have not seen that improvement, and we've actually seen deterioration. And up in the upper left-hand corner, the 3-month change map, you can see that a lot of that, especially over portions of extreme East Texas and Louisiana, has been really over the last 3 months. As I said, this has been a fairly wetlining winter through this region. And again, on the contrary, the western U.S. has been fairly dry, as well as portions of the southeast. And going to the next slide, we'll get into a little bit of the outlook here. And we'll start off with the precipitation product on the lower left. And what you can really see is pretty much the whole eastern U.S. is expecting some fairly good precipitation over the next 5 days. And we start seeing this bullseye that's showing up over East Texas, Arkansas, Louisiana, and Oklahoma. There's precipitation taking place in Oklahoma and portions of Kansas and extreme North Texas as we speak right now. And over the next 5 days, it looks like it's looking at the 1, 2, and 3 day QPF that this precipitation is going to stick around for a while, with several pieces of energy moving through the region, especially highlighting those areas of extreme precipitation. Now, 8 inches of rain over the 5 day period, again, is going to continue to fall over that same area that has seen much of this precipitation over the last several months. As far as temperatures go, what we're seeing is a fairly warm pattern over much of the U.S. Again, those areas that are associated with the rainfall are expected to see temperatures of below normal. But for the most part, very warm through the U.S., especially over the upper high plains, where temperatures are going to approach 20 degrees above normal for this time of year. And we'll go to the next slide. 8 to 14 day, the temperature product really stands out, that the odds of much of the country being above normal for precipitation, especially through the Great Lakes region, is quite high. And we see some cold air encompassing Alaska and over the west coast. And then on the precipitation side of things, it looks like it to be a fairly active pattern maintaining itself, at least through the next 8 to 14 days, where chances of above normal precipitation linger through much of the central U.S. and into the Pacific Northwest. And that dry pattern over the southwest and eastern U.S. seems to be holding on, at least what we've seen over the last several months. So continue to watch as this evolves, again, looking at the more shorter-term forecast as they come out. Next slide. Again, we have the monthly and seasonal forecast here. And through the month of March, the upper two pictures of this graphic are showing fairly warm temperatures through much of the U.S., especially again over that Ohio River and Great Lakes regions, but extending into the southern U.S. as well. We're seeing through the month of March that the odds of below normal precipitation are still existing through the region from Arizona all the way through Florida. Again, this is going to vary as the weeks go on, but as the first part of March has happened, we're seeing that this has not been the case in some of these regions. Again, for the seasonal, down on the bottom two images, I have some circles just highlighting the area of interest for most of us on this call. And we continue to see the temperature probability maintaining a high probability of above normal temperatures. And I wanted to focus on that a little bit because going into where we were last year, it not only was the dryness part of the reason of why drought was so substantial through the southern plains and the periphery regions around that, but temperatures played a big role in that. So as we watch these outlooks continue to come out, now this one's already going through the end of May with the high likelihood of above normal temperatures, I think we need to keep that in the back of our mind that even with the precipitation that we have, watching what the temperatures do is going to play just a bigger part of how this drought is going to go moving forward, not only with precipitation. And then you look at the next graphic to the right. Oh, go back one frame, please. On the precipitation outlook for March, April, and May, we do see this dry signal starting to maintain itself, especially over the desert southwest, but lingering on through Texas and along the Gulf Coast into the southeast. So realistically, the improvements that we're seeing are great, but the temperature and precipitation outlooks through the end of May really show some concern that it won't take a big flip of the switch, so to speak, to get us back into a pattern where drought could be intensifying, spreading, or developing through this time frame. Next slide. We've been talking about how we were in La Nina last winter as well as into this winter, and where are we going? And you can see in the upper left-hand graphic that the blue lines are showing the La Nina probability, and as we move forward, it does look like this La Nina is going to continue to subside through May, June, and July. We should be fairly low odds of seeing that La Nina continuing, and you see on the green bar that the neutral conditions seem to dominate through the first part of summer. And then we start seeing this El Nino signal start to show up. Realistically, there's not a lot of skill this time of year in predicting that far out as far as where we're going to be next fall, but it does show that, yes, the La Nina is subsiding in more neutral conditions, and then just the prediction plume in the lower right-hand corner of where we can expect to be going, and it does show neutral conditions all the way out through next fall, which tends to be where the consensus is going right now. Next slide. And that takes us to the seasonal drought outlook. Again, we're seeing a lot of that drought persisting across the southern United States, and even further development out in portions of the central Rockies and western U.S., and even over the northern plains. They've also had a very dry winter and some soils that have been dry through last fall as well. We do see some improvement again through the east part of Texas into Louisiana and portions of the southeast, but that gradient of the areas that are receiving that precipitation to those that are not is going to stay fairly strong. So again, this goes out through the end of May, and it does line up quite nicely with some of the other outlook products from the Climate Prediction Center. And next slide. And that is it for me. If you have any questions on this portion, please type them in. If not, I'm going to pass this on to Mark Svoboda from the National Drought Mitigation Center.
All right, thank you, Brian. All right, let's just jump right into this. Next slide talks a little bit about, you've seen these slides lead off the SCIPP webinar series now since last October, but we felt it was probably about time to give you a little bit more in-depth look as to how we make the product and sort of how it's tied to various policy decisions around the country. It is a joint partnership between the National Drought Mitigation Center, U.S. Department of Agriculture, and NOAA. Specifically within NOAA, we have the Climate Prediction Center, and we have the National Climatic Data Center, and we have the Western Regional Climate Center. So it does rotate between 10 or 11 authors, give or take. And what we have seen happen over the last several years is the growth of our on-the-ground expert list of 325 so folks, and I'll go into the demographics of that in a little bit more detail later. Next slide. Go ahead. Okay, yeah, so the objectives, just touch on a key couple points here, and that is that the drought monitor is not a forecast. I think sometimes some people still think that we're showing a prediction of drought, and that's really what the seasonal drought outlook is for by the Climate Prediction Center. So we're not trying to do that. We're not trying to declare drought for anybody, although several states do use it as one of the triggers or indicators. Many times it's not the sole indicator. And so it is really a current snapshot of where drought is occurring today as we know it, based on the best available science, impacts, and information from that expert group that I mentioned earlier. Next slide. The scientific backbone is based on a ranking percentile approach. This allows us to look at several parameters, integrate them together, knowing that they have different units, they have different periods of record. It's sort of like alphabet soup when you throw all that stuff together, but one thing we can keep consistent is based on any one parameter, we can look at driest to wettest, hottest to coldest, highest stream flow to lowest stream flow, whatever the case may be, and rank those and start to look at sort of a convergence of evidence. Originally, when we set up the drought monitor, there were probably 5 to 6 or maybe 7 key indicators because that's all that was really available, and it was available at a very coarse resolution, and it was only available weekly or monthly. Well, as you'll see throughout this talk, we've really integrated in a lot more real-time, near real-time, shall I say, gridded or point-based data instead, but all of that we try to follow this ranking percentile approach. Okay, and the other key thing I'll say here is that the first category, yellow, is also not technically a drought classification. It's more of a heads up, either going into drought or perhaps coming out of drought and recovery mode. Next slide. Okay, I won't spend much time on this because we've already talked about it, just showing you the current snapshot. We'll go to the next slide. So, depending on where you are in the country, we have to keep in mind sort of the regional influence, the seasonal influence of various indicators, how well they work or don't work at certain periods of the year for certain regions around the country. For example, right now we're really paying attention to what's happening with regards to snowpack in the west. That's what delivers water during their dry season, and they have a distinct wet season, dry season, or bimodal distribution of precipitation in the case of the monsoon in the southwest. So we're looking at things that are more snow-driven or derived. What's the amount of water in the snow? The surface water supply index, stream flow forecast, reservoir levels, etc. Because that's what's going to drive delivery of that water later on. In the Midwest, it's totally different. We're looking at what's in the soil moisture with regards to crops and potential for yields of various crops throughout the growing season. So based on that, you're going to look at different indicators in different regions based on the time of the year. So it does vary. Next slide. This just shows the distribution of our 325 expert users. As of about a year ago, you could see we only had just shy of 300 experts on this list. The only states not represented are just a handful now up in the Northeast. Since this time, I think we do have somebody on from one of the weather forecast offices in Alaska. But pretty good distribution here, excellent source of knowledge and experience that they bring to play to tell us that these indices and indicators make sense. A lot of times they don't marry up one-to-one, and it may not jive correctly with the impacts we're seeing on the ground. So we do use that to adjust which indicators do best, again, based on the season and based on the region. So that allows us to sort of be on top of that by using that feedback from the field. Next slide. This just starts to show you a collage. I think the next 2 slides, this shows you sort of how we've changed to get a lot more data in near real time, station-based or gridded from, say, satellite information, and I'll have a few slides on that in more detail later. Go to the next slide, please. This is showing, again, that next generation of products and tools that our partners have worked with us on, whether it be soil moisture modeling, whether it be a new hybrid way of combining radar, precipitation from radar combined with gauge data, as well as upper elevation snow instrumentation called the SNOWTEL network, USDA maintains through NRCS. Next slide. So, as I mentioned up front, when we first started, had about 5 to 7 indicators we could look at. And now, last I did it 2 weeks ago, that was upwards of 80 to 90 indicators at various, obviously it's some of the same indicators at various time intervals. But the point is as you look at this is just a suite of maps that USDA produces for us. And then the Climate Prediction Center also does the same. Next slide. Let's just skip forward to the next slide while we're at it. That just gives you a flavor. I wanted to show you kind of the essential tools of the trade here. Obviously, you don't want to answer the phone. You need a lot of caffeine and 2 monitors, and sometimes that's not enough. Next slide. So what we try to do when you first come in is look at, okay, first of all, let's get a handle on the short term. Where did it rain last week? Did it rain within the drought-affected areas? And was that enough to cause improvement? Weighing the short term versus the long term, getting input from the field, what impacts are out there. Then if we have no rain in those areas, we can start to explore, is that enough to degrade it, make it worse? Or if it's an area that wasn't under drought, is that enough that they should be in abnormally dry or drought? Next slide. We typically look at a lot of time periods, anywhere from 1 month to 60 months, and every time in between. And it does vary. Some of the indicators aren't available at all of those time scales. Obviously, the precipitation temperature parameters give us the most flexibility. Next slide. ACES is a big one we use from the regional climate centers under NOAA. We use this to look at a variety of things. Particularly, this is updated daily, which is very nice. It's gridded. It's based on station though, so I can display this by station instead of on the gridded interpolated view that you're seeing in these examples. And I can zoom down to some of the regions. So it's a very flexible tool that we can look at precip temperature and the SPI. Next slide. This just gives you an example of what I was looking at a couple weeks ago at the end of January, February timeframe. What you're seeing here is the amount of precipitation since the last drought monitor was done. That's the color of the dots. You can see the various colors. When you get up to the green, the cyan, and the fuchsia color, like in Louisiana and eastern Texas, those are the heavier rainfall amounts. All those squiggly lines on top of them are last week's drought monitor vectors. So we can look at the D1 or D0 through D4. That's in the legend on the bottom left. And I can quickly ascertain whether it rained in my drought areas or it didn't rain in my drought areas. And then I want to look at, was that enough to improve it? Was it enough to move it from a short term to a long term, et cetera? Next slide shows stream flow. Maybe it rained a lot, but those stream flows are returning quickly back to a normal flow standard. We need to temper the short-term effect versus the long-term hydrological droughts that still remain entrenched. So all those large fuchsia-colored and dark red, those are the D3 and D4 category stream flow values that we look at to sort of weigh the short-term versus the long-term benefit of those rains. We can see this, how nice and wet it's been up in the northern U.S. and how parts of the southeast and Texas have been dry. Next slide. This is just another example of an overlay over another precipitation product that we can look at. Next slide. Another example over modeled soil moisture in the top 1 meter of the profile. Notice how the drought monitor vectors match up pretty decently with these. And so we kind of use these to sort of do a sanity check on the models as well. And for us, so it's a two-way street. So if there's a big area of drought, say for example up there in northwest Nevada, why weren't we showing that on the drought monitor? And that's something I looked at over that 2-week period and actually worked with locals there on the ground, and we actually did expand drought in that region not just based on this product solely, but based on a convergence of other products that were showing the same story. Next slide. This is showing the snow water equivalent percentiles, the amount of water in the snow on the same ranking percentile scale as the drought monitor. This is critical in the West, where you've got distinct differences between what's happening at the top of the mountains and what's happening in the valley floors, and they can be totally different stories. And grazers of rangeland there for livestock producers have a totally different concern than those that are just concerned about the amount of water that will be there for them to use for irrigation or to supply a municipal city come the dry season. Next slide. Next slide. We started to incorporate more and more the last couple years remotely sensed data. This is satellite-derived vegetation drought response index, partnership between USGS, ARROS, National Drought Mitigation Center, and the High Plains Regional Climate Center. And that's been a valuable tool for us to look at a much higher resolution. This is a 1 square kilometer product, so we're very much a sub-county scale here. We can use that to sort of fill in the gaps where we don't have observed data, which we know there's a lot of gaps out there. These aren't perfect tools either, but when we use them in tandem, it does help fill in some of those gaps. Next slide. Just another example of the original one we used back in '99 when we started the drought monitor. So that's sort of the grandfather, that's the vegetation health index. And the next slide shows sort of the Teach-Byram drought index for fire type behavior. That's what we used, and several of the states produced this on a state level or a regional level through some of the climate centers or RCCs. Next slide. So I can't overemphasize the amount of feedback and input. This collage just shows a variety of inputs we're getting every week from states in your region, including New Mexico, Texas, Oklahoma, Arizona, all the way, just about every state now, we're getting it from the state climatologists or the regional climate centers. It's really changed the way we do this. And where we've gone with that now, if we can go to the next slide, is sort of these states working together or working within the state with their monitoring groups to provide more of a unified voice for helping us put this product together. When I do the math, there's no way we can look at 50 states in 2 days or 2.5 days of that. And we don't get all the final 7-day data until the actual last day we're doing the math. So it's really an iterative process. And this feedback now, North Carolina started it sort of at the state level. Now we've got basins doing this. We've got NIDIS helping support that. We've got some of the RCCs doing that you see with this webinar and the Southeast Climate Consortium. And individual states in there as well. Next slide just shows some of the products that they produce. I'll skip over in the interest of time. We've seen these. From the NIDA standpoint, the first one that really started giving us feedback directly, and I think this was a breakthrough because it was in the West where we can never get enough input on the impact of snow and what it means to folks out there. The Upper Colorado River Basin was supported by NIDIS to put on these webinars. And at the end of that webinar, after the various groups go through their briefings of stream flow and snowpack and vegetation and all the usual suspects, they come up and the author typically tries to sit in on all these. At least I know most of us do. We can't get to all of them, but most of the time we do. And then we'll talk about, okay, here's that graphic on the right there. Here's where the drought monitor sits this week. What are the recommendations for moving that and why? And we kind of go back and forth and try to come to a consensus. So it's been a very useful process. Next slide shows that following on the heels of that was the next NIDIS pilot in the southeastern United States in the Apalachicola, Chattahoochee, Flint basin there between Georgia, Alabama, and Florida. And so there we're getting a briefing now on a frequent basis as well that helps us, I think, do a better job of depicting drought. But again, it's a little different approach because it's at the basin level and you've got a lot of partners, and so it does give that unified voice. Next slide. Objective blends are the other key products used. These were the original. You can see these large delineation blocks within each state. Like take Kansas, for example, there in the middle. You can see a nice grid of 9 boxes, but that's a pretty coarse resolution product based on one value, for each of those climate divisions. That's what we were dealing with when we first started. What we want to do is take these grids to or take these blends to a gridded basis at a much higher resolution and update them. Look at the inputs. Short term on the left, you can see basically everything is 90 days or in and weighted differently. If we go to the next slide, you'll see for the long term, and notice how the picture, if you can go back one slide, notice the short term, how it's wet in Louisiana, Mississippi, Texas. If we go forward to the next slide, and how you notice California was very dry on the first one. Now notice how the long-term drought, hydro drought, remains. So the blends do give us that perspective. They were done for folks that want to sort of separate out the short-term and the long-term drought. And the weighting scheme is now, instead of 90 days and in, or at most 6 months and in, now we're basically 6 months out to 60 months with the long-term. And in the West, where the fuchsia outlines, we have a different formula with a different weighting scheme that was done with the Western experts' input. Next slide. You want to get real technical for every state and every climate division every week. This table's updated to show you where each parameter falls within our ranking percentile scheme. Next slide. Okay, last couple slides. I just want to focus on, well, how's the drought monitor used in policy, by the media, by the public? You can see here, it really made some splashes early on. In 2002, the nasty drought there around a good chunk of the United States. The dried milk program used the drought monitor as a trigger for that program for livestock as supplemental feed. In 2008, the drought monitor was included in the Farm Bill. And since that time, many states included it in their trigger systems for drought in their state. One of our goals was really to heighten awareness of drought, because it's one of the costliest disasters. It has a large footprint, but it doesn't have a lot of the structural damage or loss of life that you see every day on the Weather Channel with tornadoes and hurricanes and flash floods. So how did we heighten visibility? I think we've achieved that goal. It's on the Weather Channel all the time too, though, now. So we do go side by side with these other disasters, and I think that's a positive. It's used to brief governors, congressional committees, and the president, and as a pillar of the NIDIS portal at drought.gov. Next slide. I should also say that collaboration between those agencies, that's all done with no budget. It's an in-kind contribution. It's in-kind contribution from our partners in the field at the state and regional level. So it's really a testament to their commitment to make the product work, and that's what makes it unique. So going forward, I won't have time to go through all of these. You can see in the Farm Bill, the big one was the Livestock Forage Disaster Program. That's the one in the Farm Bill. That's the one, if you're D2 for 8 consecutive weeks, any part of the county, you're eligible for 1 monthly payment. If you're at D3 or D4, then it's eligible for multiple payments depending on the length of time in D3. And D4, any given week, if you're in there just for 1 week, you're eligible for the maximum amount of payments. So that's how it's used there. For the National Weather Service, they use it if a D2 hits their county warning area. They issue a drought information statement that has impacts and a whole lot of good information in there. And the Internal Revenue Service uses it as an extension of replacement period for livestock sold during drought based on drought. So if they had to cull their herd just to make ends meet, they have a deferred window that tax is deferred where they can replace the cost of replacing that herd. And so the IRS uses the D2 as a trigger during the growing season. And they've been doing that for several years now as well, I think about the same amount of time. Next slide. So my last slide will just focus on where do we go from here with the drought monitor, and then later on we'll open it up to questions from you folks. Again, we're always open to integrating new technologies, tools, and indicators. That's what makes this product unique as well. We're able to capitalize on the latest and greatest indices or technology, whether it be remotely sensed or on the ground. We're trying to take impacts into account more and more. The new drought impact reporter is helping us do that. We switched from hydrological agricultural to short-term and long-term. There's a whole lecture on that alone, but suffice it to say, there can be some concerns during the winter with lack of snow for soil moisture that we wouldn't call agricultural drought necessarily, because there's no crops growing or anything growing for that matter at that time in the northern U.S. We want to take those blends I showed you to a gridded basis and explore which inputs to go into it. And we want to incorporate more and more remotely sensed data regards to evapotranspiration and temperature. You're seeing the winds here lately the last few weeks around the U.S. Those do a major job of sapping moisture out of the ground. How do we do a better job of capturing flash drought with those type of tools? And then continue to coordinate with these states and basins with their assessments, and how do we integrate that up into the national product? So we'll continue to listen to what y'all have to say. It's a living product, and we hope that this talk has shown you a little bit more. We could spend a day talking about it, but for now I'll stop there, and my contact information should be on the next slide. Thank you. For now, we'll turn it over to John Nielson-Gammon, Texas.
Yeah, thank you, Mark. I'm going to talk about the important component of drought monitoring alluded to, which is the local input, because the drought authors have to deal with 50 states and all sorts of issues, and they aren't necessarily as familiar with what's going on locally as the people who are there locally. So on the next slide, there's different sorts of input. Some states or river basins provide coordinated input and come to a consensus on things. In other states, such as Texas, there's input from various individuals. I tried to give a comprehensive view, but there's a lot of input from people in local weather service offices and other interested parties, and that can include some of the products I'll talk about later, and also just plain rumors and impacts from someone calling in and saying this is what's going on in this location, or doing a survey and finding out what's going on in a region, or just driving through an area and reporting back to the Drought Monitor on how conditions look subjectively. All of that is useful information. Objective measures are fine, but it's nice to have ground truth. So the purpose of the input, there's fine scale information that can be provided from different products developed on the state level. The interpretation of what the different objective drought indicators mean is important in relationship to indicators and impacts. So, for example, there are certain times of year when short-term drought in Texas is more important than other times of year. In the wintertime, it doesn't matter a whole lot how much rain falls in the short term, and so the impacts are inherently less. But in the summertime, it's possible to have a flash drought develop with just 1 month's worth without rainfall that can cause significant impacts. And those things, which vary within the state, as well as among different states within the country, are things that is important to find out from locally what's going on. Next slide shows an example of a local product. This is the Keach-Byram Drought Index, which was developed for the Texas Forest Service, used to help locally with burn bans, but of course it's a high-resolution product that is useful for indicating aspects of short-term drought severity. The next slide shows a product that we've generated at the Office of the State Climatologist, based on the same input, which is the Stage 4 precipitation analyses produced by the River Forecast Center, that we've converted that into an SPI, and based on the concepts of blends of different time scales, we've developed what we call SPI blends, and to ease the interpretation with respect to the Drought Monitor, we've scaled them in the same manner that the Drought Monitor scales drought, and produced a mirror image scale on the other side to indicate wet conditions. So the particular image shown there is our most recent blend for roughly annual time scale, which shows how, despite the recent rains, there's still large portions of the state that are still in exceptional or historic drought levels. Next slide is intended to illustrate that there's sometimes the objective indicators give conflicting information, and at the national level, it's not always possible to drill down and find the time to reconcile them. So that's where local knowledge can come in handy. So, for example, stream flow maps, they're showing levels relative to historic values, but they don't interpret which of those gauges are on managed streams versus which ones are reflecting natural flow, and so forth. And so you can often get half of the gauges showing things are perfectly normal and half of them showing things are historically low. And it can be up to local experts to help differentiate that and report back as to which ones truly indicate the drought conditions. Next slide. Some of the impacts are especially local, and since drought is to some extent defined by its impact, that can affect the drought monitor depiction. So, for example, right now, agriculturally, the primary impact of the Texas is winter wheat. And so it's helpful to know what the critical periods of rainfall are in particular parts of the state for the crop, what's the status of the crop, and how much of the crop status been affected by factors other than specifically drought, such as dust storms are sort of a secondary impact of drought, but they have a big impact on the wheat crop. So the local information there reports back on which parts of the state the short-term rainfall matters and how big of an impact is it having. Next slide. There are challenges with dealing with local information, particularly with local input, because someone can say, well, the crop out here is really bad, but how do you translate that into drought monitor levels in terms of impact, as those are defined on essentially a percentile basis. So in principle, you want to know how conditions compare to what they've been over the past 100 years. Generally, is simply not available information because, for one thing, crops have changed over that time. So you have to do a little bit of expert analysis and figure out, well, what's that mean in terms of the current level of drought? It's useful to obtain documentation from the report, like, saying things are really bad is kind of nice, but saying that crops are, the height of the corn is only 6 inches, whereas normally it should be 18 inches, is the sort of thing that a DM author can actually interpret. Some challenge in balancing opposing viewpoints, and often those opposing viewpoints are the local input versus the drought monitor author, who's taking a broader view of things and is ultimately responsible for the product. And ultimately, the drought monitor author rules it's his product. He puts his name on the bottom of it, and if there's a conflict, the local input must necessarily graciously yield to the power of the drought author. And it's critical that this really be a national product, because with all the things that it's being used for, it's extremely important that there be no biased information in it. Sometimes local input can be self-interested input. For example, the worse the level of drought, and the greater the amount of relief. And so it's in the interest of local producers to have the drought monitor show the worst conditions possible. This year, I've gotten no complaints from the drought monitor among agricultural interests. The way I managed to do that is to ensure the drought monitor showed exceptional drought everywhere, so everybody got all the money they wanted. It worked out really well. But that's not usually how it happens. And then finally, a lack of understanding what the drought monitor is really trying to show. It's not necessarily showing the level of impact on a historic level, or it's not showing how bad it is compared to how bad it could be. It's showing essentially the meteorological contribution to drought and drought impacts. So, for example, someone recently told me that the drought monitor must be showing just agricultural drought because it showed improvement as soon as rain began. Certainly hydrologic drought wouldn't respond that way. Well, the drought monitor is giving one number to summarize all of drought. And so, for example, if conditions are D4 for agricultural drought and D2 for hydrologic drought, drought monitor will show fairly rapid improvement with rain, even though there may be no improvement at all well and the hydrology. Second comment, drought monitor showed improvement, but the river is still bone dry. Well, if the river is dry 1 year out of 10, then there's certainly room for improvement. That could mean D2 conditions, D3 or D4, and the river condition is simply not going to differentiate between those. So the basic message, which is encapsulated in the final slide, I don't know exactly who said this, but I've heard something like this for a long time. Everybody complains about the drought monitor. Nobody ever does anything about it. The more input that comes from local conditions, the more information the drought monitor authors have to work with, and the better the product that is ultimately put out there on the table. With that, I'll turn it over to Chad McNutt to talk about the NIDIS system.
Okay, thanks, John. I'll try to wrap this up pretty fast. So I'm going to give you a bit of a summary on the National Integrated Drought Information System. We're housed within NOAA at the Earth System Research Laboratory in Boulder, Colorado. And it's a fairly small office. The director is Roger Poolwardy. The deputy director is Jim Burden. We also have Lisa Darby in our office and myself as kind of the primary core team, as well as Robin Webb. Next slide, please. So NIDIS has been discussed for some time, or a program like NIDIS has been discussed, but it was really formed in 2006 through the NIDIS Act. And the purpose of the NIDIS Act was really to enable the nation to move from a more reactive way of dealing with drought to something along the lines of being more proactive, to really trying to manage the risk and impacts really before they occur. And one way of doing that is really having better information, having more timely information that leads to reduced impacts and costs related to drought. And so within the NIDIS Act, there are really kind of three key objectives. One was to improve coordination for national drought monitoring and forecasting systems, recognizing that there's a lot of entities and information that currently exists that's very good, but really there was a fundamental lack of coordination among them. The second thing was putting up an interactive drought information clearinghouse. We did that in 2007 through the drought portal. It's drought.gov. And then finally, the last thing that we were asked to do was improve information that supports better preparedness and planning. And that's really what I'm going to focus on for the remainder of the time we have is how we've been going about that. And one of the ways we've been doing that is by trying to test how you do drought early warning. And taking from all the information that you've heard previously today, taking that information and then trying to put it into some larger system that provides timely information in a way that, as I said earlier, reduces impacts and costs related to drought. Next slide, please. So this is a map of really kind of the three key places. They're highlighted in orange there that we've been testing out how to do drought early warning. The first one, which is being led by Jim Burden, is in the Upper Colorado River Basin. That started in, I guess, around 2008. And then about 2009, we started working in the southeast in the Apalachicola, Chattahoochee, Flint River Basin. And then most recently, we've been working in California. But just for what we have time for today, I'm just going to focus on Colorado and the southeast, and then I'm going to turn back towards what we've been doing in the southern plains. Next slide. So this is just to show you. You've already heard from Mark and others the tools that are currently available. There's quite a few of them. And so we know there's a lot of information out there, but how do we communicate that information to decision makers? How can agencies and citizens work together to mitigate the impacts of drought, taking all this information that we have? And so that's really kind of our challenge. Isn't always necessarily creating new or better information, but really trying to work with what we have. So next slide. So this is just a brief summary of some of the things that's been going on in the Upper Colorado and some of the things that we've been looking at. The first is looking at indicators and triggers for decision makers. What are those key indicators that are used, and what are the triggers associated for making management decisions? So of all the information out there, there are surely gaps in what are those? Are we making good use of the measurements that we already have? And then what about our current observational systems? Do we have any gaps there in terms of stream flow, snow tell sites, soil moisture, reservoir levels, etc.? And then, what tools are necessary that aren't sort of meeting the needs of folks. And in this case, a lot of it is evapotranspiration, really trying to monitor the snow and what we might expect in terms of runoff. And then finally, what do we not know in terms of water demand and use? Since a lot of what goes on in the Colorado is based on demand that comes from, say, Denver and some of the other large municipalities. So it's not necessarily water that's sitting on the Front Range, but water that's being pulled over from the Upper Colorado. So understanding water demand and use is fairly critical. One of the main things that has come out of the pilot so far, and you've already heard this that was mentioned by Mark Svoboda. Next slide, please. Is the work that Nolan Duskin, the State Climatologist of Colorado, and the Colorado Climate Center has been doing on these weekly drought assessments. And they're not always weekly. They really start ramping up when it gets close to the runoff season. But when we started testing this out, their first approach was to think about maybe coming up with their own sort of basin monitor, Upper Colorado Basin monitor, similar to the Drought Monitor, the USDM, but it would be focused on just the Colorado. Well, as things evolved, they found that it was more valuable to them to actually have local input into the national U.S. Drought Monitor process. And so that's what's really evolved out of this. And some of the things that's occurred since they've been doing these drought assessments and providing local input into the USDM is that it's changed just through the process of being aware and doing these weekly assessments. It's actually improved their communication to other parts of the state, and they've now expanded not beyond the Upper Colorado, but to the whole state of Colorado. So next slide, please. So the second place, the ACF, the Appalachicola-Chattahoochee-Flint River Basin, has been a little bit differently, in how we've approached the project. Water hasn't always been a contentious issue out there. They've sort of came to this late in the game and really have come to it fairly intense in the last probably 20 years or so. There's a lot of litigation going on in the basin, and there hasn't been the development of understanding that you've seen in the West, even though there are contentious issues, of course, in the West. But they're really getting into this, and so a lot of what we've been doing in the ACF is bringing people together and trying to develop common understanding of the basin in this case. And so we've been talking about, what does better monitoring and forecasting mean? What triggers, again, are people using? We've heard that people are really interested in a municipal supply drought index tool for water providers. And then, as I said, communication has really been lacking in the basin. So what are ways to efficiently disseminate and communicate information? And one of the things that we've done, similar to the Upper Colorado, is we've put together these drought assessment webinars. And Mark had mentioned those as well, and those are now providing kind of that local input into the U.S. Drought Monitor. We've also been doing drought outlook forums as well. As we've been working in this basin, La Nina conditions started to develop in 2009, 2010, and as these conditions started to develop, the Southeast has a very strong signal to the El Nino Southern Oscillation phenomena, as does Texas and the Southern Plains. But this really kind of gave us a leg up in terms of early warning and trying to forecast, at least on a seasonal basis, what conditions might look like. And so we did our first climate outlook forum in 2010 and started this outlook forum process there. And we did another one last year in December to give people kind of an idea of what they might expect for winter, since that's sort of their critical recharge season. And the last thing that we've tried to do is really increase education and awareness, and we've been doing that in a couple ways through newsletters and fact sheets, as well as part of this outlook form process. We've been trying to provide education and awareness of what drought kind of looks like. Next slide, please. And then finally, turning our attention to what's been going on in the southern plains of Texas and the surrounding states. This wasn't on our at least our initial list of places to work. We wanted to kind of test it out in these very different areas like California, Colorado, and in the southeast. But as the drought started to really evolve in 2010 and into 11, we started to have conversations with some of our partners, and this would include like the Drought Mitigation Center, Mike Hayes and Mark Svoboda, and Victor Murphy at the National Weather Center for the Southern Region, and Dave Brown, who's our NOAA Regional Climate Services Director, as well as Mark Schaefer and the Southern Climate Impacts Planning Program, and then of course the NIDIS Program Office. We started to have conversations about what could we do to kind of respond and give people an idea on how conditions are changing and what they might look like on a seasonal basis. And so once we started to come up with some ideas, Mark Schaefer had already started planning a workshop. I guess it was in Memphis, a state drought planning workshop, and he was trying to take advantage of the fact that people had their attention sort of turned towards drought. And well, we thought that's a great idea to get some of the states started to think about at least reassessing their drought plan, or maybe even in some cases creating their first drought plan, but also sharing information on how to do drought planning. While he was doing that, we started talking about, well, could we do an actual climate outlook in the southern plains? And so taking what we had learned in the southeast, we started developing a drought outlook form, and we started working with the state climatologists that had been already doing a ton of work in their respective states. This would include John Nielson-Gammon, of course, who you just heard from, and Dave Dubois from New Mexico, and Renee McPherson and Gary McManus in Oklahoma, and Barry Keim in Louisiana, just to name a few. And we started to plan this drought outlook forum. The first one we did was in Austin in June of 2011, and then we followed up in Fort Worth in November. And the idea was to give people a sense of how the drought had evolved, how it had evolved, and then what we might expect in terms of the next 3 to 6 months for conditions. And so we had a variety of people at these workshops. We had pretty much across the sectors that are affected by drought. We had the media there as well, trying to communicate what impacts had been seen and what they may expect going forward into the future. And so what I just show here on the screen is just the various states of the drought monitor, going from March 8th to 2011 all the way to the last week's map. And you can see at least from March to June it changed fairly rapidly. The last thing that we kind of did was to stand up these webinars that we're on today. And again, some of this was learned from these other pilots that we've been working on in the Upper Colorado and in the Southeast. And so it's good to see that they've been working. We've had a strong turnout for it. And then the last thing was, we're starting to think about, how do you sustain this process that we've been doing? How do you sustain these webinars and keep the information flow going, given that we don't do a drought outlook forum, but every maybe 6 months or so. So how do you keep these things going? And I think the webinars have been a great way to do that. So just to wrap up, some of the next steps for NIDIS is to, one of the things we've talked about is doing a drought assessment for the Southern Plains. So look at how the drought evolved, how did the drought impacts evolve as a result, to really kind of nail down what drought looked like in terms of impacts and cost to folks, but also what led to these conditions? Why did we have these conditions for so long? The other things that we're doing is we're developing our pilots in other areas. I've mentioned California. We're also looking at the Missouri River Basin. Lisa Darby will be leading up a Carolinas pilot, and then we're also looking at working in the Chesapeake Bay. All these areas have very, very different ways of dealing with drought and responding. We're also looking at how to sustain these outlook and drought assessment efforts. And so you've heard from a variety of them today, from the ACF to the Colorado, and even supporting other groups. I know we've got a group that Dave Dubois is running in New Mexico, and then there's an effort that the State Climatologist in Florida is running as well. How can we provide support to keep these groups going? and how can we provide support to keep the outlooks going as well? Can we get the states more involved in leading the efforts, et cetera? And then the last thing is helping to facilitate a drought coordinator network that could work with the states in cooperation to help disseminate information to hopefully give them an idea when droughts are starting to rear their head, sort of early warning that conditions are starting to lean that way, and to provide them some support for dealing with it. So I think that's it. If you have any questions, please, please type in your box there. Thank you.
I'd like to thank all of our presenters today, and I hope this has given everybody a better look at kind of behind the scenes, pulling up the hood and seeing how it all works. I hope it's been instructive. I'd like to mention a couple of things. First of all, that several of the presenters mentioned the importance of local reports, and there is the Drought Impact Reporter, which is a great way of making sure that what you're seeing on the ground, what you're hearing, gets to the Drought Monitor authors, the state climatologists, and the others who provide that input or take a look at those local details. And that email address is droughtreporter.unl.edu. We have it linked on our PDF summaries as well as on, I believe, on the resource slides in here. So please use that. Please encourage others who are talking about drought to use that so that we know that where there are impacts and also where there are not impacts. We'd also like to mention that that Chad and Dave have been working on creating another drought forum, a discussion or workshop in Lubbock, and targeting April. Those are still kind of in the preliminary stages working that out, but please keep an eye open for that, because we recognize that this extreme and exceptional drought is still continuing out in West Texas and New Mexico, and hope we'll be able to focus on the impacts in that as well. So and we still have several state climatologists on the line. Dave Dubois and Nancy Sullivan are on there, as well as John, of course. And Mary Knapp had to leave, but if you have any questions for them, please feel free to type them in. I believe John wanted to give a brief update on some of the changes in Texas in the last couple of weeks. John? Okay, well, I guess we hopefully had it covered in the talk. So if you have any questions, please go ahead and type them.
Mark, this is Barry from Louisiana. I just wanted to give you a quick update, if it's all right.
Okay, fantastic. Thanks, Barry.
Yeah, I snuck in. I had some complications getting on at the beginning of the call. But anyway, we've had some pretty dramatic improvement across Louisiana. Much of the same improvement has occurred across the eastern half of Texas as well. But over the last 3 to 4 weeks, we've had some pretty substantial rains. Very un-La Nina-like situation where we've had some of these Gulf storms forming off the coast of Texas and having the storms track across Louisiana. And obviously it's had taken a big bite out of our drought. And at this point, we really only have a touch of severe and exceptional drought left in the state in the extreme southeast and northwest corners of the state. And everywhere in between, I mean, we're doing much, much better. We still have a little bit of moderate drought, but by and large, things are really looking up for the state of Louisiana. So hopefully this pattern will continue.
And this is John. I was muted before. Sorry about that. Yeah, we've had the 11th wettest December through February on record. We actually had a break of about a week and a half without rain, which has been useful for getting crops in the ground. But it's really quite a variation from the eastern half, where we're just basically looking at hydrologic recovery, to the western half, where we're getting dust storms because there's no soil moisture at any level. So quite a contrast, and we're now approaching the spring, which is the wettest time of year. So that's going to tell the tale as to how we go into the summer.
Fantastic. And it's good to note that contrast. That it's when you have a state the size of Texas and you talk about the 11th wettest, it tells you just how wet it's been in the east, because there hasn't been that much improvement out in the western part. I'd like to mention as a reminder that the materials will be posted to the drought portal in the Southern Plains section, which you can access through the on the main drought.gov site through the menus on the upper left part of the screen. And we'll have a 2-page PDF summary of this posted, and that'll be on the drought portal as well as the Facebook page and website. The webinar recording will be posted to a SCIPP YouTube page, and as well as getting the summary out on those other parts. Our next webinar will be on March 22nd. It'll be short and briefing like we did the last time. The next full webinar will be on April 12th with a focused topic on wildlife and environmental impacts. As always, we encourage you to continue to spread the word to make sure that all those dealing with aspects of this drought are a part of this larger community. As Chad mentioned very well, I think, showing how we're all learning from each other, including outside of this region, the experiences from those pilots. And we're contributing, our participation in this process helps these other regions that are coping with drought learn as well. So I hope you feel a part of that and appreciate all your involvement. We encourage you to pass along PDF summaries, webinar announcements, or any other information linked on these various sites. Thank you for your time today. We look forward to continuing this conversation with you in the future. Have a great day and enjoy the rain for those of you who are getting it.